So let's start section 7.3, multiplying and dividing rational expressions. So let's recall let's say we have the following. Let's say 2/3 times 5/6. I can multiply these by multiplying numerator and denominator, but if there happen to be anything that I can simplify first by cancellation, I should do that. And so I can divide both 2 and 6 by 2. I get a 1 and a 3. And then I could multiply 1 times 5 is 5, 3 times 3 is 9. And similarly, 2/3 divided by 5/6. I would rewrite division as multiplication by the reciprocal. And if I can do any sort of cancellation, 6 divided by 3 is 2. I would then multiply. 2 times 2 is 4. 1 times 5 is 5. So let's do on page 270, sorry, page 270. Let's do problem number 2. 5y² over 6 times 3y. In exercises 1 through 14, perform the multiplication and write the answer in lowest terms. So even if I don't tell you, you should always write your answer in lowest terms. And so 6 divided by 3 is 2. 5y² divided by y is 5y. 5y times 1 is 5y. 2 times 1 is 2. And so my answer is 5y over 2. Let me do problem number 4. Four x to the 4 over 10 x squared. 15 x to the 5 over 12 x cubed. And so let's multiply this. So first, 4x cubed, 4x to the 4th divided by 4x cubed is x. 12x cubed divided by 4x cubed is 3. 15x to the 5th divided by 5x squared is 3x cubed. 10x squared divided by 5x squared is 2. And so let's multiply this. X times, x times 3x cubed. I could actually divide, let's do it with this color, I guess, blue. 3 x cubed divided by 3 is x cubed. And 3 divided by 3 is 1. So let's multiply. X squared times x cubed is x to the 4. 2 times 1 is 2. And so I get x to the 4 over 2. Let me do problem number 8. 3xy to the 4 over 4x squared y squared times 12x to the negative 2 y to the 4 over 9xy. Okay. So in this case, since they have a negative exponent, let me just multiply across. So yes, so let me multiply across. Yeah, so negative needs to go to the denominator. So maybe what I'll do is, because of that, maybe I'll just multiply the numerator times numerator, and then after I've multiplied that out, bring it to the denominator. So 12 times 3 is 36. X times x to the negative 2. Well, you have the same base, you add exponents. 1 minus 2 is a negative 1, so x to the negative 1. X to the y to the 4 times y to the 4 is y to the 4 plus 4 is 8 over 4 times 9 is 36. X squared times x is x to the 3rd. Y squared times y is y to the 3rd. And so let me bring the negative exponent to the denominator. So I have here 36 y to the 8 over 36 x cubed y cubed times x, bringing the negative exponent from the numerator to the denominator. And so I have here 36 y to the 8 over 36 x cubed times x is x to the 4 y to the 3rd. And so I can divide both numerator and denominator by 36y to the 3rd. So 36y to the 8 divided by 36y to the 3rd is y to the 5th. 36x to the 4th y to the 3rd divided by 36y to the 3rd is x to the 4. And so I get y to the 5th over x to the 4th. And that is my answer. Let me do problem number 12. (18) a to the 4, b to the 2, over 25 q to the 2nd, p to the 3rd, 125 q to the 6th, p to the 6th, over 27 a to the 6th, b to the 2. Okay, so I can divide both 18 and 27 by 9. And so let's divide. And I can divide, so a to the 4th is smaller than a to the 6th. B squared is the same as b squared. So let's divide this term, 18 a to the 4b squared, by 9 a to the 4th b squared. And so I get 2. Divide 27 a to the 6th b squared by 9 a to the 4th b squared. So I get 3 a squared. And so let's divide 125 q to the 6th p to the 6th by 25 q to the 2 p to the 3. So when I do that, I get 5 q to the 4 p to the 3, and 25 q to the 2nd p to the 3rd divided by 25 q to the 2nd p to the 3rd is just 1. And so I get 2 times 5 is 10. Q to the 4th, p to the 3rd. So p to the 3rd, q to the 4th, over, well, 1 times 3a squared is 3a squared. And that is my answer. Let me do problem number 14. Let's just see. For the a, shouldn't be divided by 2, meaning a second on top and a to the 3rd. Okay, so let's just say, so you have here an a to the 4th, and you have a to the 6th. Since 6 is bigger than 4, then you would subtract 6 minus 4 to get 2. So it should be a to the 2nd in the denominator. Okay, let me do problem number 14. Two x squared y over 5y squared, 10 y to the 3rd over 8yz, 4x squared y over x to the 3rd. Okay, so let's see. 10y cubed divided by 5y squared is 2y. 5y squared divided by 5y squared is 1. Doesn't really matter. Oh, I see. That gives you 8. 4x squared y divided by 4y is 2x squared. 8yz divided by 4y is 2z. Okay. I can divide 2 divided by 2 just gives me 1. And x squared y divided by x squared is just y. X cubed divided by x squared is x. And so I get y times 2y times, there's an x squared up there, isn't there? Well, let's do one more cancellation with this one. I think I did. 2x squared divided by x is 2x, and x divided by x is 1. Okay, so now I get here, y times 2y times 2x is a 4x y squared. 1 times z times 1 is z. And that is your answer. Let me do problem number 16. 2x cubed over 3x squared divided by 5x to the 4 over 15x to the 6. In exercises 15 through 20, perform the division and simplify. So let me do that. So let me first change division into multiplication by the reciprocal. And so instead of dividing, I'm going to multiply by the reciprocal of 5x to the 4 over 15x to the 6. And so I have 15x to the 6 over 5x to the 4. And so let me do that. Maybe I'll just multiply straight across since there's going to be so many cancellations. Well, so if you notice here, I have 15x to the 6 divided by, well, 3 times 5 is 15. X squared times x to the 4th is x to the 6. So these cancel with that. And so all I have remaining after I've done that cancellation is just the numerator, 2x to the 3rd. And that is your answer. Let me do problem number 20. 5x to the 4 over 3x cubed divided by 15x squared over 9x to the 4. So first let's rewrite division as multiplication by the reciprocal. So let's take multiplication. The reciprocal of this term on the right is 9x to the 4 over 15x squared. Let me get rid of the parentheses. And so I have here 5x to the 4 over 3 cubed is 27x cubed times 9x to the 4 over 15x squared. Okay, and so let's do some cancellation. I can divide both of these terms here by 5x squared. So 5x to the 4th divided by 5x squared is x squared. 15x squared divided by 5x squared is 3. I can divide this term by 9x cubed. I get an x. I can divide this term by 9x cubed. I get 3. And so, I get x squared times x is x cubed. 3 times 3 is 9. And I am done. Let me do problem number 22. X plus 8 over x squared minus 9 times 2x minus 6 over 2x plus 16. In exercises 21 through 80, perform the indicated operations and simplify. So first, let me factor everything before I do this. So I have here x plus 8 over, I can write x squared minus 9 is the difference of squares, so I can factor it into x minus 3, x plus 3. I can factor from 2x minus 6, there's a 2 in common, so what remains is x minus 3. I can factor from 2x plus 16, 2. So what remains is x plus 8. The x plus 8's cancel. The 2's cancel. The x minus 3's cancel. So all that remains is 1 in the numerator, and x plus 3 in the denominator, and a 1 in the denominator. And so we get 1 over x plus 3. And that is your answer. Let me do problem number 26. a squared minus 9, a squared minus 16, a minus 4, a minus 3. And so I can factor this into a minus, again, there's a difference of squares, so a minus 3, a plus 3, over, well, again, difference of squares, a minus 4, a plus 4, times, well, a minus 4 over a minus 3. The a minus 3's cancel. The a minus 4's cancel. So all that remains is a plus 3 over a plus 4. And that is your answer. Let me do problem number 32. Actually, let me do problem 28. Let me do problem 28. X squared minus 4x plus 4. 1 over x minus 2. And so I can write x squared minus 4x plus 4. That's a perfect square trinomial. This is just x minus 2 quantity squared. And let's write that over 1 times, well, 1 over x minus 2. I can cancel one of the x minus 2's. And so I just get 1x minus 2. And so my answer is x minus 2 divided by 1, x minus 2. Let me do problem number 32. X squared minus 9 over x plus 2 times x squared minus 4 over x minus 3. And so this is the difference of squares, x minus 3, x plus 3 over x plus 2. Difference of squares, x minus 2, x plus 2 over x minus 3. So one of the x minus 3's cancel. One of the x plus 2's cancel. So all that remains is x minus x plus 3 times x minus 2. And that is your answer. Let me do problem number 38. Oh, wait, let me do 38. X squared minus 9 over x plus 3 times x squared minus 8 over x minus 3. And so I have a difference of squares. And so this is x minus 3, x plus 3 over x plus 3. 8 is not a perfect square, so I cannot factor this over the integers. This x squared minus 8 is not, is irreducible over the rationals, over the integers. But it is, you can factor it over the irrationals, because you could write it as x minus the square root of 8 times x plus the square root of 8. But here, I only factor over the rationals, so I'll just leave it as x squared minus 8. I can cancel x plus 3, x minus 3. So all that remains is x squared minus 8. Let me do problem number 44. 6 minus a minus 2a squared over 4a squared plus 3a minus 10 times 3a squared plus 7a minus 20 over 2a squared plus 5a minus 12. Okay, so this is equal to, so let's factor. I want 6, so 2 times 3 is 6. I want 2a squared, so a and 2a, and I want a minus, so let's do plus there. And now let's check if this is correct. So I get 6 minus 4a plus 3a gives you a minus a minus 2a squared. Okay, so I factored it over. I want a 4a squared, and so 2a, and I want a 10, so a 5. Oh, a 4a and an a. I have a 5 and a 2. And I want a plus, so let's do a plus there. And so I have here 4a squared minus 8a plus 8a minus 5a gives me plus 3a minus 10. And now let's factor 3a squared, so we get a 3a and 20. So I get a 4 and a 5. And let's do this. 3a squared plus 12a minus 5a is 7a minus 20. And let's factor. So it's a 2a, and I want a 12 here, so a 4 and a 3. And I want a plus. So 2a squared plus 8a minus 3a is plus 5a minus 12. And now let's see if I can do any cancellations. So I have here a plus 4's cancel. A plus 2 and 2 plus a, they cancel. And I get a plus 1. Since they're both in the same, everything's the same, the only difference is the order. Then I put a plus 1 in the numerator. And let's cancel the 2 minus a and the 3 minus 2a. They're the same, the only difference is the order. And so I put a 1 in the denominator. And well, since there's a minus in the middle, I'll put a minus 1 in the numerator. And so I get a minus, because there's a minus in the numerator, 3a minus 5 over 4a minus 5. And that is your answer. Okay. Let me do problem number 48. A squared plus 2a minus 35 over 12x. Okay, divided by 9x minus 3x over a squared plus 4a minus 21. Okay, so let's rewrite this. division as multiplication by the reciprocal. And so taking my reciprocal, I get a squared plus 4a minus 21 over 9x minus 3x. And so I get here, let's factor. And so this is a monic polynomial, so I can just factor this easily. So this is A. Drop down the plus times minus is minus. I want two whole numbers whose product is 35 and whose difference is 2, 7, and 5. Again, this is a monic polynomial, so it's easy to factor. So I'll bring down A here. There's a plus times minus is minus. I want two whole numbers whose product is 21 and whose difference is 4. So 7 and 3. And 9x minus 3x is 6x. And so nothing to cancel. Nothing cancels because, well, let's see. There's nothing in the bottom to cancel with these a's and nothing to cancel on the top with the x's. And so I just multiply everything. So my answer is a plus 7 times a plus 7 is a plus 7 squared, a minus 5, a minus 3 over 12 times 6, 72, x times x squared. And that is your answer. Let me do problem number 56. X squared minus 7x plus 12 over x squared minus 16 divided by x squared minus 2x minus 3 over x squared minus 2x minus 24. And so let me rewrite division as multiplication by the reciprocal. And so I have here x squared minus 2x minus 24 over x squared minus 2x minus 3 So this is a monic polynomial, so I can factor it nicely. Bring down the minus, times plus is minus. I want two whole numbers whose product is 12 and whose sum is 7, 4, 3. This is the difference of squares, so x minus 4, x plus 4. This is a monic polynomial, and so I'll factor it nicely. Bring down the minus, times minus is plus. I want two whole numbers whose product is 24, whose difference is 2, 6, and 4. Again, this is a monic quadratic, so I can factor it nicely. Bring down the minus, times minus is plus. I want two whole numbers whose product is, whose product is, and let me just check if oh good, I didn't get rid of you yet. Here, wait. Oh, I may, can you still see right in the background is the question. Hopefully you can. Whose difference is, whose product is 3, whose difference is 2, so 3 and 1. And so let's cancel the x minus 4s, x plus 4s, x minus 3s. So all that remains is, I can probably put it here, x minus 6 over x plus 1. And that is your answer. Okay, let me do, let's say problem number 68. x squared plus 4x plus 3 over x squared y divided by x squared plus 2x plus 1 over xy squared. And so this is equal to, let us change division into multiplication by the reciprocal. X squared plus 4x plus 3 over x squared y times the reciprocal, xy squared over x squared plus 2x plus 1. So let's factor. Again, this is a monic polynomial, so it factors nicely. I have a plus, I'll bring in the plus, times plus is plus. I want two whole numbers whose product is 3 and whose sum is 4, 3 and 1. I have x squared y, and xy squared over. Again, this is a perfect square trinomial, so x plus 1 quantity squared. And so, maybe I'll just write it as x plus 1 times x plus 1. And so, the x plus 1's cancel. X squared y divided by xy is x. Xy squared divided by xy is y. And so what remains is x plus 3 times y over x plus 1 times x. And that is your answer. Let me do problem 72. X squared minus 1 over x squared plus x minus 2, x cubed plus 8 over x to the 4th plus 4x squared plus 16 divided x squared plus x cubed plus 2x squared plus 4x. Okay, so let's rewrite this division as multiplication by the reciprocal. So let me just copy all this again. And so take the reciprocal, so it's x cubed plus 2x squared plus 4x over x squared plus x. And so now let's do a whole bunch of factoring. So difference of square, so x minus 1, x plus 1. This is a monic quadratic, and so it's x, bring down the plus, times minus is minus. I want two whole numbers whose product is 2 and difference is 1. So 2 and 1. This is a sum of cubes. So I'll do the sum of cubes formula. So x, cube root of x cubed is x. Cube root of 8 is 2 times, well, let's write this as x squared. So square the first term, change sign, multiply by x and 2. So you get 2x plus 4, 2 squared, all over x to the 4th plus 4x squared plus 16. I could factor that if I wanted to, but I'll just leave it for a second at least. Let me factor a x in common. So what remains is x squared plus 2x plus 4 over, factor out an x, so you get x times x plus 1. So what remains is, well, let's see, the x plus 1's cancel, x's cancel, the x plus 2's cancel, the x minus 1's cancel. So all that remains is x squared minus 2x plus 4 times x squared plus 2x plus 4 over x to the 4th plus 4x squared plus 16. Let me rewrite this as x squared plus 4 minus 2x times x squared plus 4 plus 2x. And now I can use my special product formula to multiply this out, because this is the product of the sum and difference of two terms, which is just the difference of their squares. So it's x squared plus 4 squared minus 4x squared over x to the 4th plus 4x squared plus 16. And so I can multiply this out. Maybe, let's see, maybe I'll try to get a little bit more room. I'll move this up slightly. Okay, so this is equal to by the special product formula, x squared plus 4 quantity squared is x to the 4th plus 8x squared plus 16 minus 4x squared over x to the 4th plus 4x squared plus 16. Well, 8x squared minus 4x squared just gives you 4x squared. And now I notice that the numerator and denominator are the same, so I can cancel them. And so I get 1 for each of these. And so my answer is 1. And so everything cancels, and I just get 1. Let me do problem number 74. Eight x squared minus 26x plus 15 over 3x squared minus x minus 4 times 3x squared minus 7x plus 4. 2x squared minus 7x plus 5 divide 4x squared minus plus x minus 3 x squared minus 1. And so let's change the division into multiplication by the reciprocal. So let me just copy everything down. 3x squared minus 7x plus 4 over 2x squared minus 7x plus 5 times the reciprocal. So the reciprocal is x squared minus 1 over 4x squared plus x minus 3. And so let's factor. And so I have here 8x squared is 2x, 4x. 15 is 5 and 3. And so I get 8x squared minus 6x minus 20x is minus 26x plus 15. I have here 3x squared, so 3x x. And I have here 4. So 4 and 1. And let's check. 3x squared plus 3x minus 4x is minus x minus 4. And now let's factor. So I have 3x, x, and I have a 4, so 4 and 1. And let's check. 3x squared minus 3x minus 4x is minus 7x plus 4. And now let's check here. 2x, x, 2x squared minus 2x minus 5x is minus 7x plus 5. And let's factor difference of squares, x minus 1, x plus 1. And this is 4x, so 4x and x plus 1. And so you get 4x squared plus 4x minus 3x is plus x minus 3. And let's cancel. So the 4x minus 3's cancel. The 3x minus 4's cancel. The 2x minus 5's cancel. The x minus 1's cancel. The x plus 1's cancel. That's it. And so what remains is x minus 1 over x plus 1. And that is your answer. Let me do problem number 76. X squared plus 7x plus 10. X squared minus 3x minus 10. X squared plus 3x minus 10. X minus 4. X minus 4. X squared minus 7x minus 10, plus 10. Okay, so this is equal to. Let's get rid of the parentheses so I can flip what's in the parentheses. So that becomes, so I'll change division into multiplication by the reciprocal. So I have here x squared plus 7x plus 10 over x squared minus 3x minus 10 times the reciprocal. X minus 4 over x squared plus 3x minus 10. Good. Now I have a division here. And so division is multiplication by the reciprocal. So let's take the reciprocal. So I get x squared minus 7x plus 10 over x minus 4. So I've converted each of these divisions into multiplications by the reciprocals. Now I can factor. And so this is a monic polynomial, so it just factors nicely. Let me bring down the plus, times plus is plus. I want two whole numbers whose product is 10 and whose sum is 7, 5, and 2. Again, bring down the minus times minus is plus. I want two whole numbers whose product is 10 and whose difference is 3, so 5 and 2. X minus 4. Again, monic polynomial. I want bring down the plus times minus is minus. I want two whole numbers whose product is 10 whose difference is 3, 5, and 2. And lastly, x. I bring down the minus times plus is minus. I want two whole numbers whose product is 10 and whose sum is 7, so 5 and 2. And the x plus 5's cancel. The x plus 2's cancel. The x minus 4's cancel. The x minus 5's cancel. The x minus 2's cancel. So everything cancels. You just have a whole bunch of 1's here. And so you get 1. Let me do problem number 78. Two x squared plus 3x minus 2 over x plus 3 divided by 3x squared plus 7x plus 2 over 4x squared plus 15x plus 9. And so let's change division into multiplication by the reciprocal. 2x squared plus 3x minus 2 over x plus 2 times the reciprocal. 4x squared plus 15x plus 9 over 3x squared plus 7x plus 2. And so let me factor 2x, 2, 1. And now let me check that this is correct. So 2x squared plus 4x minus x is plus 3x minus 2. Let me factor 4x, x, 3, 3. And now let's check. 4x squared plus 12x plus 3x is 15x plus 9. Let's factor 3x, x, 1, 2. And let's check. 3x squared plus 6x plus x is 7x plus 2. And now let's cancel. 2x, x plus 2's cancel. And that is it. And so your answer is 2x minus 1 times 4x plus 3 times x plus 3 over x plus 4, 3x plus 1. And that is your answer. Let me do problem 79. P squared minus 4, p squared minus p to the 6 divided p squared minus 3p minus 10 over p squared minus 8p plus 15 times p squared minus p minus 2 over p squared plus 3p plus 2. And so let's change division into multiplication by the reciprocal. So we get p squared minus 4, p squared minus p to the 6. Let's change division to multiplication by the reciprocal. And so I'll take the reciprocal of each of these. And so since this is a product, then you multiply numerator times numerator, denominator times denominator. So therefore the numerator was just a product of the numerators. The denominator was just a product of the denominators. Therefore, taking the reciprocal, I just get the denominator becomes the numerator. The denominator becomes the numerator, and the numerator becomes the denominator. Okay, and so now let's do some factoring. It's the difference of squares, so p minus 2, p plus 2. I can factor out a p to the second. So what remains is p minus is 1 minus p to the 4, which of course is the difference of squares. And so what remains here is, and so I have a monic polynomial, so p minus 5 p minus 3. I have a minus. I bring down the minus times plus is minus. I want two whole numbers whose product is 15 and whose sum is 8, 5, and 3. Again, this is a monic polynomial. I bring down the minus times minus is plus. I want two whole numbers whose product is 10 and whose difference is 3, so 5 and 2. And let's factor this. So a monic quadratic. So I bring down the plus times plus is plus. I want two whole numbers whose product is 2 and whose sum is 3, 2 and 1. And lastly, I bring down the minus times minus is plus. I want two whole numbers whose product is 2 and whose difference is 1, 2 and 1. And let's see what I can cancel. Ooh. Oh, that's fine. The p plus 1's cancel. The p plus 2's cancel. The p minus 2's cancel. The p minus 5's cancel. Oh, and then that's it. So this is equal to p plus 2 times p minus 3 over p squared. Actually, 1 minus p to the fourth is the same as 1 minus p squared times 1 plus p squared. And you really can't, well, you can factor that further. Let me just factor it completely. So this is p plus 2, p minus 3. Of course, leaving it as 1 minus p to the fourth is still correct. So, but it's nice if you factor everything as much as possible. So 1 minus p times 1 plus p. You can't factor the sum of squares. And so this is your answer in completely factored form for each term in the numerator and denominator. Let me do problem number 80. Three x squared 14x minus 5, x squared minus 3x plus 2, 2x squared minus 3x minus 2, 3x squared plus 2x minus 1, divide. 2x squared plus 11x plus 5, 2x squared minus 1. And so I don't need the parentheses, so I can just rewrite it without the parentheses. 3x squared plus 14x minus 5 over x squared minus 3x plus 2, 2x squared minus 3x minus 2 over 3x squared plus 2x minus 1. Let's change division to multiplication by the reciprocal. 2x squared minus 1 over 2x squared plus 11x plus 5. And so let's rewrite this so I can factor 3x minus 1, x plus 5. And so let's check. 3x squared plus 15x minus 1x is 14x minus 5. And let's factor. This is, again, a nice monic polynomial. So bring down the minus times plus is minus. I want two whole numbers whose product is 2 and whose sum is 3, 2 and 1. Let's factor. 2x squared is 2x. X 2 and 1. So I get 2x squared minus 4x minus plus x is minus 3x minus 2. Let me factor this. It's 3x squared plus 3x minus x is 2x minus 1. This is a difference of squares, so x minus 1, x plus 1. And let's factor this, 2x plus 1, x plus 5. So I get 2x squared plus 10x plus x is 11x plus 5. And now I can cancel x minus 3, x plus 5, 2x plus 1, x minus 2, x minus 1, x plus 1. So the only thing remaining is just a 2 in the numerator. So your answer is 2. Okay, oh, and then that's it. Oh, darn. That's the only thing I had on that page. Oh, well. And so I guess that's it for today. And so I will, oops. Oh, I just saw that. Can you scroll up to 72 again really quick? Oh, I didn't see that. Scroll up to 72 really quick. For some reason I didn't hear the, oh, a whole bunch of stuff. Sorry about that. I didn't see the middle line last denominator. Okay. Oh, because of this. Yeah, so what I'm doing in here is I rewrote the x squared minus 2x plus 4 is x squared plus 4 minus 2x. And x squared plus 2x plus 4 is x squared plus 4 plus 2x. And this is, these terms are both the same. The only difference is a minus, that's a plus. So there's a product of the sum and difference of two terms, which is the difference of their squares. But then you know a special, so that's a special product formula. But then you use another special product formula. This is the just the sum of a plus b quantity squared. So it's a perfect square trinomial. But then the 8x squared minus 4x squared gives you 4x squared. So the numerator and denominator were the same. Okay. Number 80. Yes. Oh, it is 2x squared plus 1 plus x. Two x squared plus 11x plus 5. Okay, so I guess that's it. So let me stop this.